All right. Are there any questions what we did last time? Complex numbers. What was that? Do you have any questions about what we did last time? Complex numbers. We talked about multiplying, dividing, adding, and subtracting. What are the rules about dividing complex numbers? What can you not have on the bottom? You cannot have an I. You can have a negative on the bottom. You cannot have an I. So if you had an equation like this, what would you do to get rid of the I on the bottom? We cannot have I on the bottom. So we have to get rid of the I. We're only worried about the bottom. Yeah, because remember, once we get I squared, what does that become? It was -1, right? So we're just trying to get rid of this I. So if we multiply top and bottom by I, 2 times I is 2I. 3I times I is 3I squared. 5I times I is I squared. Yeah, so this changes the sign of its coefficient, so it becomes -5. There's no more I on the bottom. This I squared here changes that coefficient sign. So this negative goes up on top. And it changes everybody's sign. We want to have the real number first. Oops, minus. And there's your answer. It's 3 minus 2I over 5. So that's what we did. That's one of the things we did last time at the end of class. You cannot, if you have a single monomial on the bottom that has an I, then multiply top and bottom by I. That'll get rid of the I on the bottom. If you have a binomial on the bottom, what do you do? No. It's called the conjugate, remember? What is the conjugate? You change the sign in front of the I term. So it's 2 plus 3I, so it's 2 minus 3I. Five times 2 is 10I. Positive times negative is negative. 5 times 3 is 15. I times I is I squared. Remember the shortcut we did last time? Or we could do the long way. Let's do the long way. 2 times 2 is 4. Positive times negative is negative. 2 times 3 is 6I. Positive times positive is positive. 3 times 2 is 6I. Positive times negative is negative. 3 times 3 is 9. I times I is I squared. These two cancel out. This I squared changes that sign, so the bottom becomes 4 plus 9. This I squared changes that sign, plus 15. So our final answer is 15 plus 10I over 13. Did we go over this kind of stuff last time? I think it sounds easy when we do it in class, but the second you walk out that door, it stays here. So, all right, so that's where we ended up last time. Today, we're going to start section 2. We're going to get full-fledged into quadratic equations. We're done with linear equations. We're now going to do quadratic equations, functions, and inequalities. So what is a quadratic equation? A quadratic equation has this form: ax squared plus bx plus c equals 0. We call that the standard form. That's the standard form. So what does this tell us? Anytime we see a variable with the highest power being 2, in order to solve it, we have to set it equal to 0. Once we go from 0, once we get equal to 0, then we can solve it, which is what we're going to learn how to do today. Quadratic functions looks like this. The function of f of x is equal to ax squared plus bx plus c. There is one caveat here. In both of these, a cannot equal 0. Why not? Why can a not equal 0? If a is 0, what do we have left? Down here, if a is 0, it's gone. Bx plus c, that's a linear equation. Mx plus b. If ax is gone, then we have mx plus b. We have linear. So that's why a cannot be 0. We're dealing with quadratics here. And when we talk about inequalities, we're talking about areas of solutions. So if we have a quadratic equation, which is a parabola, the answer is either going to be inside the parabola or it's going to be outside the parabola. And that's what we test. But we first have to draw the graph and going from there and start going from there. There are 2 principles that we have to follow in this chapter, in this section. We have 2 principles. We have the 0 product principle. The 0 product principle. What do you think that means? Here's what it means. If we had 2 equations multiplied together, let's say x plus a, x plus b, and they equal 0. Remember, quadratic equations have to be equal 0. So if we have 2 equations multiplied together and they equal 0, what does that mean? That means, because anything times 0, if I had a times b equals 0, if a is 0, 0 times b is 0. If b is 0, it still equals 0, right? So either the first equation equals 0 or the second equation equals 0, or both. So that's what we do when we solve these things for x These are our solutions. That's the zero product principle. We take two equations, set them equal to zero, and then solve them individually. But first, we're going to have to go from our equation, our quadratic equation. We have to get these two smaller sub-equations, and then we could solve them from there. Okay, that's the first principle, the zero product principle. The second principle is called the square root principle, or the principle of square roots. It says this: if x squared equals a number, how do we solve for x? What do we have to do to both sides? How do we get rid of the square? What's the opposite of squares? Square roots. So we have to take square roots of both sides. But when you take a square root of a squared term, that means the answer can be a positive or a negative answer. So those cancel. So x is equal to plus or minus the square root of a. Let's see what that means. Let's look at an example of this one. X squared equals 4. I'm asking here is what can x be to make this a true statement? Work it out. To get the x by itself, what do we have to do to both sides? Square root it to get rid of the square. So we square root both sides. Because we square rooted an x that was squared, we got to put a plus or minus on the other side. What's the square root of 4? So it says our answers are either 2 or -2, or both. Let's test them. Let's try 2. Remember our original equation was x squared equals 4, right? This is what we have to test. If we put 2 in there, 2 squared equals 4. True. If we put -2 in there, -2 squared equals 4. So that's why my answer is plus or minus 2. That's the principle of square roots. Whenever you're solving for a number that's a letter that's squared, you square root both sides, you have to put a plus or minus in front of it. So far, so good. The first method, now we're going to start solving quadratics. The first method we're going to talk about is called factoring. Here, we'll take a quadratic equation and simplify it to 2 linear equations. So we're going to take a quadratic equation and break it down to its smaller constituent linear equations. For example, we're going to do something like this. X squared plus 5x plus 6 breaks down to x plus 2, x plus 3. So we're gonna go from a quadratic equation to two smaller linear equations. Why do we do that? It's easier to solve. What does this 2 tell us here? What is that? What's the name of that 2 there? It's squared, yeah, but what is the name in this function? What is it? What is its title? The degree. The degree is the highest exponent in equation. It's important because it tells us a lot of things. It tells us the shape of the curve. It's squared, so we know it's a parabola, either like this or like this. It tells us that we can have at most 2 real answers. Here are 2 answers. So it tells us a lot. So let's look how we factor. Before we do that, let's start with the basics. I'm going to put the same numbers up there in 4 different configurations. We have x and 2 in the first parenthesis, x and 3. The only thing changes are the signs. You could just fold the piece of paper. You could just folded it. Find the middle. So go ahead and work these out. Multiply these together. Like x times x is what? X squared. X times 3. So positive is positive is positive. X times 3 is 3x. Positive times positive is positive. 2 times x is 2x. Positive, positive is positive. 2 times 3 is 6. Combine like terms. Positive 3, positive 2 is positive 5x plus 6. So do that with the other ones. What method is this called? FOILing. We take the first term, so x times x is x squared. Positive times negative is negative. X times 3 is 3x. Positive times positive is positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Combine like terms. Since 3 is bigger than 2, the answer would be negative. 3 minus 2 is 1. So do the last 2 while I wait. I need you guys to practice this stuff. I'll give you the answers. That's what it's going to end up with if you did it correctly. X squared plus 3x minus 2x minus 6. Combine like terms. X squared. 3 is bigger than 2, it's positive. 3 minus 2 is 1, minus 6. Minus 3x minus 2x, negative and negative is a positive. 2 times 3 is 6. They're both negative, so you add them. You have to be aware of how to do this first. Know where the equations came from. This is called distributivity. We distributed everything in the first parenthesis into the second. That's distributivity. It's multiplying together. Now we're going to go this direction. That's factoring. But before we do that, I want you to look at patterns here. Let's look at this first one. The first thing I want you to look at is the first term. What does that tell us? Remember, we're factoring, so we want to break it down to 2 smaller pieces. It tells us the first terms are both x's. Because x times x is this first number. Second, let's look at the last number. What we have to do is figure this out. What 2 numbers multiplied together will give you 6? It can be 6 times 1 or 2 times 3. Then we look at the sign. If the second sign is positive, if this number here, if this sign is positive, what does that tell us? No. Then we know that both numbers have the same sign. Because where does this number 6 come from? It comes from, this number 6 here comes from 2 times 3. The only way it can be positive is if both signs are the same. The only way it can be positive is both signs are the same. If they're different, that means this one's going to be a positive times a negative is a negative. A negative times a positive is negative. But if they're both positive, both negative, the second sign's plus. So just by looking at the second sign, we know what the structure is going to be. If the second sign is negative, then the 2 numbers have different signs. And the bigger number gets the first sign. So if the second sign's a minus, that means both of these signs here have to be different. The bigger number, if this number here comes from this times this. So let's see this. So what 2 numbers, when you multiply together, gives you the 6? And if you add them, you get the middle term. So what times what equals 6? So we know the first terms have to be x's, right? What does this tell us about the signs? They're both the same. They're both going to be pluses. If this is the same, they're going to have that one. What times what is 6? When you add them, you get 5. Yes, 6 plus 1 is 7. 3 plus 2 is 5. So the numbers have to be 3 and 2. Factor that one out. So we have 2 parentheses. What goes in the first spot? Yeah, they both have x's. What about the signs? Well, its second sign is negative. If that's true, that means they have to have different signs. The bigger number goes in which spot? The first or the second? Nope. The bigger number gets the first sign. Because if the middle sign is negative, that means the bigger number has to be negative out of these two. So what times what equals 8? Since there's different signs, when we subtract them, equals 2. 8 times 1 is 8, but 8 minus 1 is 7. Yeah, 4 times 2 is 8. 4 minus 2 is 2. There's the 2. That's this 2 there. So 4 is the bigger number. It gets the negative. So 4 goes here, 2 goes there. We'll do a bunch more of these until you start seeing it better. So since we're factoring, we need to break out the parentheses. So we know the first spot, X and X. What signs go in there? Yeah, they're both the same since that's plus. They're both negatives. Because if the second sign's a plus, both signs are the first. So what times what is 5? When you add them, you get 6. Yeah, 5 times 1 is 5. 5 plus 1 is 6. So it's 5 and 1. Let's crank it up a notch. So what can you tell me so far? Both of them have X's. What, because of this being negative, they have to have opposite signs. Where does the bigger number go? The bigger number, if it's opposite signs, the bigger number has to have that first sign. So the bigger number goes there. Plus minus, no, because of the commutativity. I could put them either way. So what times what equals 28? When you subtract them, you get 12. You subtract because of this equals 12. 14 times 2, 14 minus 2. So those fit. That means 14 goes in the plus, and the 2 fits here. Okay, I wouldn't throw you in the sharks just yet. What's different between this one and the other ones we've done? It has a leading coefficient. So the first thing you should always do is, can anything factor out of all of these? Do they have anything in common? Yeah, they each have a 2. They all have a 2 in common. Here's to figure out what goes inside the parentheses. Since you factor out a 2, divide each of these by 2. Whatever's left goes inside there. So these cancel, it's just x squared. 6 divided by 2 is 3. 20 divided by 2 is 10. So whenever you factor anything, to determine what goes inside the parentheses, divide each of them by that, what you factored. And whatever's left goes inside there. Now we can try to solve it. So we know x's. What about the signs? Yep, because that's minus, so one has to be positive, one has to be negative. And the bigger one goes where? Yeah, because that's positive, the bigger number goes here. So what times rho equals 10? When you subtract them, it equals 3. 5 and 2. So 5 is bigger, so it goes in the plus. And there you have it. So why do we do this kind of stuff? Because we need to solve them. Because now it's an equation. These were expressions. There's no equal sign. Now it's got an equal sign. So what does that tell us? We need to find the values of x to make it true. So in other words, we have to solve these. Whenever you have an equal sign, you solve them. So since it equals 0, now we can try to factor it. All right. The second sign is a plus. What does that tell us? The same signs. They're both going to be positives. So what times what is 12? When you add them, you get 7. Okay. So now comes the last step. Because it equals 0, this is the product principle, the zero product principle. So we take both of these equations and set them equal to 0. Subtract 3 on the first one. And subtract 4 on the second one. To be safe, it's always best to check your answers, plug these back in the original equation. And if it works, it's great. If not, then that one doesn't work. But what do these represent? What do these represent? There are solutions, yes. But what are solutions? What's another name for solutions? If you plug these in there, it equals 0. What's that? No, they are, but they're specific plot points. What's that? These are your x-intercepts. When you say solutions, that's the same thing as x-intercepts. Remember in chapter 1 how you find the x-intercepts? What do? Set y equal to 0 and then solve for x. Set y equal to 0. Notice, what does this mean? Set the equation equal to 0. And that's what we did the first step. Because it had to be equal to 0 before we go any further. So because y is equal to 0, we're finding the x-intercepts. We'll try another one? Okay. And then we're going to increase the difficulty to have coefficients now that don't easily work out this way. Finished. What do you have to do first? What does it have to equal first? It has to be equal to 0. Remember, we're looking for the x-intercepts. So we have to move everything to the smaller numbers to the larger. Because x squared is positive over here, we have to move everything to that side. How do we move the negative 6x? Positive, yeah, do the opposite. X squared plus 6x equals negative 9. We have to get rid of 9. We have to add 9 to both sides. So x squared plus 6x plus 9 equals 0. Now we're in standard form. Now you can solve it. Let's try factoring it. So the x's go first. The second sign's a plus, which means they're both the same. They're both going to be pluses. What times what is 9? When you add them, you get 6. 3 times 3. 3 times 3 is 9. 3 plus 3 is 6. Now we take both of these equations, set them equal to 0. So you know what this means to the graph? Since both of these answers are the same, it tells us that the graph at -3 is only touching at that point. Since both answers are right there, it's telling us that that's basically, this is also our vertex. The vertex is at the point -3, 0, because it only touches one time. Let's try another one like that. We have 2x equals -x squared plus 15. So what's the first thing we have to move? Notice x squared is over here, but it's negative. X squared has to be positive. The coefficient of x squared has to be positive. So since it's on this side and it's negative, we got to move it. If it was positive, we leave it there. But since it's negative, we have to move that first. So we have x squared plus 2x equals 15. Now what? Minus 15. Very good. Both sides. X squared plus 2x minus 15 equals 0. So they're both x's. The second sign's a minus. That means what? They're opposite signs. And the bigger number goes where? The bigger number goes in the positive. So that's where the bigger number goes. So what times what equals 15? When I subtract them, it equals 2. 5 times 3, 5 minus 3. That is the hardest part right there. Figuring out those numbers. We have to do a lot of calculations there. So 5 is bigger, so it's positive. 3 is smaller, so it goes there. What's my next step? Yeah. Set them equal to 0. So we get x equals -5 and x equals. It's always going to be the opposite of what's inside the parentheses. It's always going to be the opposite. So those are my x-intercepts. Didn't we talk about the axis of symmetry last time? symmetry, not cemetery. Okay. All right. Let's try now a more difficult one with one that has a lot more numbers in it. So if A is not one, in other words, if the leading term, remember, this is AX squared plus BX plus C. If the leading term, leading coefficient is not one, and there isn't a common factor, in other words, we can't take anything out of this equation like we did last time, then you have to do it this way. Place AX squared in both sets of parentheses. So this is the first term. Second step. Do the signs. The second sign is a minus, which tells us one's going to be positive, one's going to be negative. The bigger number gets the negative. So the bigger number is going to go there. Question? Because we did the same thing, is whenever you do the signs, look at the second sign. If it's a minus, that means the signs are opposite. If it's a plus, they're both the same. And it's whatever the first sign is. All right, now, third step. Multiply A times C. So we have 3 times 10 is 30. Find what two numbers multiplied equal the product of A times C, and that, oops, add or subtract equal the middle number. So multiply the first and the last terms. You got 30. Now we got to figure out what two numbers multiply together give you 30, that when you, in this case, subtract them, it equals 1. Yeah, so it's 5 times 6 is 30. 6 minus 5 is 1. So 5 and 6 are the numbers. Who gets the plus? Who gets the minus? Yeah, since the bigger number is negative, that's first sign. The 6 goes here. The 5 goes there. We're not done yet. Factor the parentheses. There's, we have 3x plus 5, 3x minus 6. Can anything factor out of there? Can anything factor out of the first? How about the second? Yes. So nothing can factor out of here. What can factor out of the second? 3. So whatever I factor, I divide by everything inside there. So it's x, 6 divided by 3 is 2. Delete what you factor out. In other words, delete it. It's gone. So there's your factor. There's your factor. Let me get another one here. So here's another one. X squared plus 17x plus 3. Okay, what's the first step? Yeah, put 20x in both of these. What about the signs? They're both the same. They're both positive. Very good. Third step. Three equals 60. So what times what equals 60 when we, so that's plus, when we add them, we get 17. 15 and 2. Let's figure it out.
I got it. 20 times 3, right?
20 times 3 is 60. 20 plus 3 is 17.
Huh? 20 minus 3. Oh,
They both, it has to be added to equal 17.
Hmm.
Okay, this is the tough part. Let's find out. Let's take a 60. Break it down to its smallest pieces. 15 times 4 would be 60, but 15 plus 4 is 19. Unless I made a mistake. Which is always a possibility. Ah,
12.
that's 20. 17, that's 17.
Well, but that'll be 17. Instead it would be 5 on.
Yeah. Twelve and 5.
Yeah.
I had to make sure my numbers were going to add up. The way you do it is, I'll show you, is you break these things down. So what else equals? It's 30 times 2, 15 times 4. Just 5 go in there. 12 times 5. 10 times 6. And then, so those are all the factors of 60. Then you start, just add them, which one give you 17? Again, this is the hardest part. It takes the longest part, but once you get it, it's all done. So we know that it's 12 and 5. So can anything factor out of this first term? What do they both have in common, if anything? Okay, we take out a 2. So it's 10x plus 6. Can anything else go out of there? Yeah. So another 2. We'll just delete that one. So divided by 2, we get 5x plus 3. Whatever you factor out, you cancel, get rid of. How about the second one? 5. 20 divided by 5 is 4. So the answer is, the factored form is that. So get this one. So we know it's 12x and 12x. The signs are going to be, yeah, they're both the same. Since that's plus, they're both going to be minus. Twelve times 15. Is it 280? So what times what is 280? When we add them, we get 28. That's an easy one. I can do that in my head. It's 180.
Oh, okay.
Sure it is. 15 times 12. 5 times 2 is 10. 2 times 1 is 2, plus 1 is 3. 5 times 1 is 5. 1 times 1 is 1.
Oh, I had that one.
So it's 180. So what times what is 180? When you add them, you get 28. The 28 is the middle term. So let's see, 180. The easiest one there is 180 times 1, 90 times 2, or 10 times 8, or 10 times 80, not 80, 18. 10 times 18 is 180. 10 plus 18 is 28. So it's 10 and 18. Nope. Because all you're doing is typing numbers in there, but then what? You still have to write them down. This will help exercise your brain. Can anything factor out of the first one? Twelve divided by 2 is 6. 10 divided by 2 is 5. So that's good. How about the second one? Anything bigger?
Six.
6. 6 goes into 12 and 6 goes into 18. You're not wrong. You could put 3 in there, you could put 2, but then you have to do it again. So it's just that if you could look at both of them one time, you see what's they have in common. So our answer is that. Those are the factors.
What do you think sum equals to?
Right here. Because if the answer is 10 times 18 is 180, 10 plus 18 is 28. All right, so that's factoring. What we have to do now, let's look at another method. Complete the square. That previous method is good as long as it's factorable. Can you factor this one? What times what is 7? 3 times 3 is 6. It'd be 1 and 7. So 7 minus 1 is not 4. So this is not factorable. So you couldn't use factoring. So let's try another method. Complete the square. Complete the square. It has to only work on equations. You have to set it equal to 0. First step. A has to equal 1. If not, divide each term by A. We'll come back to this at the end and put it back. So this method only works when A is 1. Second step. Move the C term to the other side. Remember, it's ax squared plus bx plus c. The c term is the constant term. So our first step here is we had to add 7 to both sides. That's my first step. Third step. Add b over 2 squared to both sides. So in our case, what is b? Yeah, 4 is whatever's in front of the x. So 4 divided by 2 squared. We do it to both sides. On the left side, only do inside the parentheses. Don't square it. I'll show you why in a second. On the left side, only do what's inside the parentheses. The right side, work it out. 4 divided by 2 is 2. 2 squared is 4. 7 plus 4 is 11. Now this is where you complete the square. Because if you notice now, on the left-hand side, we have two terms that are squared and the signs. Take whatever's under the squares, put them inside there, and the first sign. Take what's under the squares and the first sign. So it's x plus 2 squared. Now, we can go on further and solve this, or we can find the vertex here. Since we're solving these, let's go ahead and solve it. Solve for x. What do you have to do first? We have x plus 2 squared equals 11. So what do you have to do first? We have to, since we're going to try to get the x, what do we have to get rid of? Well, how do we get rid of the square? Square root both sides. So we have x plus 2. What does it equal on the other side? When you square root a number that's squared, you have to put a plus minus in front of it. And subtract 2. So x equals -2 plus or minus square root of 11. And those are our two answers. X equals -2 plus square root of 11. And x equals -2 minus square root of 11. Those are my two answers, my two x-intercepts. Let's do one that we can also factor to test. Let's do this one. Let's go ahead and factor first, and then we'll do complete the square. We should come out with the same answers. What signs go there? Right, because that's negative, it's plus or minus. What times what is 27? When you subtract them, you get 6. 9 times 3 is 27. 9 minus 3 is 6. And the 9 goes where the plus is. So what are my x-intercepts? And positive, very good. It's always the opposite of what's inside there. All right, so we know those are the answers. Let's do the same equation, but this time let's use complete the square. Remember the steps. Is A 1? Yes, so check. What's the second step? Move C term. So we have to add 27 to both sides. Third step. B over 2 squared to both sides. And B is what in our case? 6 over 2 squared. 6 over 2 squared. Fourth step. On the left-hand side, only do what's inside the parentheses. 6 divided by 2 is 3. And the right side, work it out. Six divided by 2 is 3, squared is 9. 27 plus 9 is 36. Now what do you do? Complete the square. On the left-hand side, whatever's under the squares, those go in there, and the first sign. So whatever's under the squares and the first sign go inside the parentheses. We have to solve for x. So what's my next step? Square root to get rid of the square. Very good. Both sides. So that cancels. So we have x plus 3 equals plus or minus. Yeah, square root of 36 is 6. Subtract 3 from both sides. -3 plus minus 6. So that means -3 plus 6, which is 3. And it needs x -3 minus 6, which is -9. -9 and 3, which is what we found earlier. It seems like this method is a lot longer and harder, but in essence, it's shorter because at this stage here, we can find the vertex. If we had x plus 3 squared equals 36, make it equal to 0. So move the 36 that side. So my vertex is going to be at -3, -36. And we're gonna learn how to get that in a second. That's the next section, but I'll show you, this does a lot for us. Now, so far it looks pretty cool. It's just straightforward procedures. But what if this happens? Let's use complete the square here. So we have to move the 10 over. So we add 10 to both sides.
Wait, what are we doing?
Complete the square.
Change the factor?
Oh, well, I want to show you why, and we always use the factoring to test it. If I want to, I'll make this to 11 then, so you can't factor it.
Okay.
So I'm giving you something easy to work with right now. What's the next step? All right, so we have to add b over 2 squared, both sides. B is 3, so 3 over. Now here's the problem. You see, we have fractions. So we have x squared plus 3x plus 3 over 2 squared. 3 over 2 squared becomes 9 over 4. Square both of the numbers. We'll do this is 40 plus 9 over 4. So it's 49 over 4, which is 12 and 1/4. But right now, we'll just leave it as this. Now we complete the square. Whatever's in the square goes inside the parentheses, as well as the first term. Next step. Square root both sides. We have to get rid of the square, so we square root both sides. This, on this side, I can take both the top and the bottom separately. Square root of 49 is what? Square root of 4? Subtract 3 over 2 from both sides. So -3 plus or minus 7 over 2. Let's look at both of the answers. X equals -3/2 plus 7/2. And X equals -3/2 minus 7/2. Seven minus 3 is 4. 4/2 is 2. So X equals 2 is one answer. -3 minus 7 is -10/2 is -5. So X equals -5 is the second answer. And that's exactly what we would have gotten if we factored it. But the problem with this is we have fractions to deal with first. It just so happened at the end, they all factor out, they all cleaned up. But that's the problem we have with this method. You have to deal with fractions all the time. Y'all remember the quadratic formula from high school? Okay, let's see how we get it. We're going to derive the formula here. We have ax squared plus bx plus c equals 0. Let's just complete the square. What do you have to do first? Nope. Well, nope, we have an a here. So we have to divide a by everybody. We have to get rid of that a first. Remember, it has to be 1 for us to be able to use it. All right, next step. Now we move the c. What's the next step? We move the c term. Nope. We have to take the b term and divide it by 2. So we have b over a divided by 2 squared. Add that to both sides. B over 2 or b over a divided by 2 squared. This is the b term, so it's squared. Okay, this is b over a divided by 2/1. What do you do? Let's fix this inside here first. So we have b over a divided by 2/1. How do you do that? A fraction over a fraction, how do you fix that? Take the top fraction, leave it alone. Multiply it by the flip of the bottom. So it becomes b over 2a. So I took this, fixed it, and so we have it here now. On the left-hand side, we just take the first and last terms and the first sign. And put it inside the parentheses. Squared. What do you do on the right-hand side? We have to work it out. We have to simplify it to one term. So we have negative C over A. This squared goes to every member inside there. So it's B squared. 2 squared is 4, A squared. When you square a parenthesis, everything inside there gets squared. Now you have to get common denominator. This is A, this has 4A squared. So it's missing a 4 and an A. 4 and an A. So it's negative 4AC over 4A squared. Because 4A times negative C is negative 4AC. 4A times A is 4A squared, which is what we needed to have on the bottom. On the right-hand side, since we have a common denominator, we have 4A squared on the bottom. That's not, it's 2. Since we have 4A squared on the bottom, we could, all we need to do is put the top together. Let's put the B squared first, so it's not a negative sticking out there. So they both have 4A squared. I put B squared minus 4AC, so it's positives. Okay, now we have one term here. What do we do next? We can't go any further here. What do we do on this side? We're trying to get the X by itself, so what do we do? Square root both sides. So we have the square root of X plus B over 2A squared equals the plus or minus . So that cancels. So we have X plus B over 2A equals plus or minus . Let's split these up. We have B squared minus 4AC . Nothing can be done on the top because it's an equation, so we'll leave that alone. What can we do to the bottom? The square root of 4 is what? Square root of A squared? No, the square and the square root cancel. A, yeah. So square root of 4 is 2A, so it's 2A, which is good because that's what 2A is over here. Now we move it over. Subtract B over 2A from both sides. Since they're both the same denominator, there is the quadratic formula. That's how we solve. That's how we got to it. I could have just given it to you, but eventually you'll forget what it is. But this way, if I remember a procedure now. So the quadratic formula is negative B plus or minus B squared, square root of B squared minus 4AC all over 2A. where A, B, and C are real numbers. Let's look at the last one we did. To use the quadratic formula, to use this formula, you have to have it in standard form. It has to be equal to 0. Now, from there, we have to label what A, B, and C are. What's A? A, B, and C are numbers, no letters. There's 1. It's the coefficient. Remember, it's AX squared plus BX plus C. What's B? And C? Right. So all we do is start plugging things in. So B, so it's negative B is 3 in this case. Plus or minus B 3 squared minus 4 times A times C, negative 10 over 2 times A. Once you have this formula, all you do is plug in A, B, and C and work it out. 2 times 1 is 2. Negative 3. 3 squared is 9. Negative times negative is a positive. 4 times 1 is 4. Times 10 is 40. Work it out. Do the math. Inside the radical. Negative 4 times 1 is negative 4. Negative 4 times negative 10, positive 40. Nine plus 40 is 49. Square root of 49 is what? Now we have our two answers. Negative 3 plus 7 over 2. Negative 3 minus 7 over 2. 7 minus 3 is 4, over 2 is 2. Negative 3, negative 7 is negative 10, over 2 makes it negative 5. Those are my x-intercepts. The quadratic formula always works. It'll always work. It'll always give you an answer. Whether it works or not, if the answer is imaginary, it'll tell you. But it always works. And that's usually the go-to when we deal with these things. Let's do another one. Let me just make up some equation here. Four x squared minus 3x plus 5 equals 0. What's the first thing you have to do? Yeah. A, B, and C. What is A? B, and C. I would suggest to always start off by writing your formula down first to help you memorize it. So you have the equation, you have A, B, and C. Start off with this. Now start plugging in. You have the negative. What is B? B is -3. Plus or minus the square root of B is -3 squared. Minus 4 times A. What's A? 4. Times C is 5. All over 2A. A is 4. The quadratic formula is simply plug and play. Negative of negative makes it a positive 3. -3 squared is +9. Very good. 4 times 4 is 16 times 5 is 80. 800, it's 30, 5, 6, 7, 8. 80 over 8. 3 plus or minus, so 9 minus 80 is -71, because 80 is bigger, it's negative. The answer is negative. So, and since that's a negative inside there, our answer is 3 plus or minus I radical 71 over 8. Those are my x-intercepts. So what would that tell you about your graph? Since it's a complex number, what does that tell you about the graph itself? Do we have any real x-intercepts? No. It tells us then our graph is either like this or like this. It's not going to cross the x-axis. Since A is +4, it opens up. Our graph will look something like this. It'll be opening up above the x-axis, so it doesn't cross it. That's what that tells us, if you have imaginaries. Okay, it's pretty straightforward. Now, there's another thing it tells us. The quadratic formula, a part of it, tells us the number of solutions we will have. Number of solutions we're going to have. That's called the discriminant. The discriminant is going to tell us how many answers, how many intercepts we're going to have. Here's your quadratic formula. The discriminant is this part right here inside the radical. Let's think about it. If b squared minus 4ac, it could be one of three things. If it's greater than 0, if it's positive, what does that mean if we take the square root of it? Let's say if it's a positive, like 4. It says then we're going to have two answers. We're going to have two solutions. Or two x-intercepts. If it's positive, because then we can take the number, add plus or minus to the b. If it's equal to 0, if the discriminant is equal to 0, then we're going to have one solution. That's at negative b over 2a. Because if the discriminant is 0, it disappears. All we have left is negative b over 2a. If it's less than 0, we're going to have no real solutions. Yeah, no real numbers, which means it's not going to cross the x-axis. So no real numbers, no x-intercepts. Are you all brain dead yet? Or you want to keep on going? Because that's it for this section. Section 2, that's it. We went through factoring, quadratic formula, and complete the square. Now I'll show you how to use this stuff to find the vertices, whether it's maximum, minimum, how we're gonna start graphing equations now. Which actually, and that was the question when I first was interviewed many years ago. They said, prove the quadratic formula. Okay, so I started proving that binomial equations and quadratic equations do exist. Then how to solve it using factoring, then how to solve it using complete square. Then if those two work, then I could derive the quadratic formula. And I went through the whole thing and it went. So yeah, it's pretty straightforward to me. And the rest, yeah, you can see, this is used as a checking mechanism. If you only have one answer, well, this will tell you what to look for. If it touches the graph at only the x-axis at one point, that's it. Okay, yeah. Let's go ahead and I'll make sure you do the homework. I need you guys to practice this stuff before, what's today? Monday? Oh, yes, before Wednesday. So yeah, try to do a couple of these. Don't do all of them. Just do a couple of them and see what it feels like. And because from here on out, we're going to move and start graphing these things. And the next chapter will be the tough one. After we finish that one, it's all downhill from there. The stuff gets much easier. Chapter 4 is the most difficult. Chapter 3. It's not that, this stuff's not that difficult, I hope. It just takes practice. You too. Yes, I sent out progress reports.